on to the last exercise, the third class lever. So a first class lever, the fulcrum is between the effort and the load, or the thing that you want. The effort is what you pull with. So the second class lever, we saw the fulcrum is at the end. You lift it up at the very end, and then the force was in the middle. So an example of that would be a wheelbarrow. If you think about when you lift up a wheelbarrow, the dirt is in the middle and the wheel is at the end. The wheel is the fulcrum, the dirt is in the middle of the wheelbarrow, and you're lifting up at the end. So we just did that in exercise number 6. Now, exercise number 7, we're doing a third class lever. So the effort is at the very end and the load is in the middle. I'm sorry, the load is at the end and the effort is in the middle. Now think of a canoe. When you're canoeing and you have an oar. What you do is you grab the oar in the middle and at the end. So the end, you grab an oar at the very end of your hand, and that's the fulcrum. Then you move the oar with the hand in the middle. That's the effort. The load is the water pushing against the oar at the very end. So that's an example of a third class lever. You get a distance disadvantage on that one. I'm sorry, you get a distance advantage on that one. But the third class lever, you actually get a force disadvantage. That means you have to push a lot harder with the third class lever, but sometimes you want a distance advantage. So what we're gonna do is we're gonna put the same 200 gram mass that we had before at 80 centimeters. The fulcrum is gonna be at 5 centimeters. So the 200, so what was that? That was 221.9 grams from the previous exercise. So this 200 gram mass plus its mass hanger, that's 221.9 grams at 80 centimeters. So you draw that out on your diagram. The fulcrum's at 5, so to find the torque, you have to find its weight times not 80, but 80 minus 5, because remember, you have to, what's the difference between this position and the fulcrum? It's, if this is at 5, and this mass is at 80, that means the distance is 75 centimeters, right? Or 0.750 meters. So you can find that torque, and again, it's a clockwise torque, that's a negative torque. The meter stick is also contributing to the negative torques. So the entire meter stick acts as if it's at the center of mass. So you have to have an additional torque just due to the meter stick, and that also is a negative torque or a clockwise torque. So the weight of the meter stick, which we've been using it so much, you should know it by heart, times what? Is it 0.5? No, because it's not 50 centimeters from the fulcrum. The center of mass is not 50 centimeters away. It's 45 centimeters away from the fulcrum, right? Because the fulcrum is at the 5 centimeter mark. So the weight of the meter stick times 0.45, and that'll be the torque due to the meter stick. So these are really quite large torques. Now what I'm going to do is I'm going to exert one counterclockwise torque at the 50 centimeter mark. So let's make sure this is hanging at 0. Yep. Now this also is a 20 Newton scale. The last scale I use is a 5 Newton one. It's going to be more than 5 Newtons. So that's why I have to do this. So what I'm going to do is I have to grab, and I'm going to move this up. You can't see anything now, but once I have it balanced, you'll be able to see it, because I'm going to hold it up, the spring scale up here. And I got to grab this and put this at 50 centimeters, and this is hard to do because I can only use one hand. I got to use all 3 hands for this. All right, so I'm lifting everything up, and you can see actually that it's quite a lot of force. And was it 5.75 it looks like. See, it's how it's halfway between 5.5 and 6. Oops, I moved. I gotta keep my meters, this thing at 50. It's still about the same, 5.75 newtons. 5.75 newtons. So that is my counterclockwise or positive force acting at the 50 centimeter mark, or 45 centimeters from the fulcrum. So this force times 0.45 will be my positive torque. So you add up the 2 negative torques, they should equal the positive torque. And that's it.